The simple design method you learned during the past lectures depends on several sludge parameters. One of them was the sludge volume index, or SVI. Normally, activated sludge has a sludge volume index below 150 milliliters per gram, which is considered a good value. However, sometimes things get out of hand. The sludge volume starts increasing and the sludge will not settle anymore. We call that bulking sludge, and how that can be prevented is today's topic. When the sludge volume index is below 100 milliliters per gram, we speak about very well settling sludge. Aerobic granular sludge from the Nereda technology can even reach SVIs below 50 milliliters per gram. However, the other side of the coin is bulking sludge, when sludge volume indices are above 150 milliliters per gram. The consequence of bulking sludge is decreased settleability and eventually sludge washout, so an increased effluent suspended solids concentration. There are different forms of aggregated growth and floc formation. What is most preferred are nice and dense flocs without filamentous outgrowth. However, short filaments can form the backbone structure of sludge flocs. If they grow outside the flocs, they can bridge to other flocs during settling, forming very open structures, increasing the SVI. They can even trap small air or dinitrogen bubbles, preventing flocs from settling and causing foam layers. Many types of filaments should and can be avoided when the right process parameters are chosen. Microscopic observation of deactivated sludge can be an early warning system for bulking sludge problems. It is very important to recognize the organisms in the activated sludge, since they can tell you a lot about the condition and control of your sewage treatment plant. Filaments as well as floc formers could be recognized on morphology, but often applied fish method could help identifying the microorganisms present. Mr. Eichelboom, who also supplied most microscopic pictures for this lecture, developed a control strategy for activated sludge plants based on microscopic observations. Parameters influencing sludge characteristics are the following. A fluctuating loading rate can influence the growth of filaments. Fluctuating loading rates can be due to fluctuating influent flow rate or influent concentration. The latter can be caused by illegal discharges or accidents. Also, the composition of the influent can enhance filamentous growth. Do you remember this graph? I showed you this one before on the competition of microorganisms in mixed culture systems. Which organism will grow fastest and win the competition at low substrate concentrations? And which one at high substrate concentrations? Indeed, as substrate concentrations in the bulk liquid are low, the filaments will proliferate. Substrate can be understood here as electron donor, electron acceptor, C source, or nutrient concentration. Also, the absence of certain trace elements can enhance filamentous growth, as more often observed in industrial wastewaters than in sewage treatment. Fungal hyphae can grow at low pH. Filamentous sulfide oxidizers as thiotrix especially grow on septic wastewaters that are pre-fermented and contain volatile fatty acids and reduced sulfur compounds. The introduction of anoxic tanks in sewage treatment plants also diminished the occurrence of many types of filaments, since these species are not able to grow in the absence of oxygen. The origin of the influent is something that is difficult to change. However, fluctuations in loading rate or food to mass ratio can be prevented with good control. Good process operation can also influence the competition advantage of filamentous organisms. For example, microtrix species will proliferate at low oxygen concentrations, and can be prevented by increasing the dissolved oxygen concentration over 1.5 milligram per liter, especially in the last phase of the treatment when ammonium concentrations are low as well. If these oxygen concentrations cannot be maintained, one should consider improvements on the existing aeration system. The other design limitations are all related to the presence of local septic conditions in the installation. For example, if sludge stays anaerobic for many hours instead of the desired 30 minutes due to a low return sludge flow or wrong inlet design. When sludge bulking is observed, the sludge volume index can be decreased by dosing iron or aluminium. The aluminium increases the density of the flux and leads to increased settleability. Also, products that improve size or structure of the flux can be dosed, like polyelectrolytes. A more harsh method is chlorine or hydrogen peroxide dosing. Due to the high surface volume ratio of filaments, these disinfectants will bring more harm to the filaments than to the floc formers. The dosage is important to avoid killing the entire population. A typical value for systems with a low hydraulic retention time, like 5 to 10 hours, are 2 to 8 grams of chlorine per kilogram sludge per day. Chlorination can cause turbid effluent until the sludge is free of filaments. This is one of the reasons why it's not often used anymore in European treatment plants. Last measure, at really extreme circumstances, one could even decide to replace all the sludge with new one. Both nocardia and microtrix parvicella can cause extensive sludge foaming in activated sludge systems, mainly due to their hydrophobic cell surface that can attach to small air bubbles, forming foam layers on aeration tanks and final clarifiers. Microscopic observation can distinguish the two types of microorganisms. Where microtrix has thin filaments extending from the floc, nocardia has short filaments contained in the floc structure. Especially the thick brown colored nocardia scum layers are known, and layers as thick as 1 meter have been observed. Nocardia is typically observed when the scum layer is trapped and kept inside the system. Also, fat and edible oils in the influent is associated with the presence of this organism. Skimming off these layers or chlorine spraying can be used to control the foam as well as effective degreasing measures. However, in modern, well-dimensioned sewage treatment plants, the most observed filament is the microtrix, where other filaments are pretty rare. A very effective measure in bulking sludge control is the introduction of a selector before the aeration tank. A selector is a small contact tank with a residence time of 20 to 60 minutes, in which the influent is mixed with the return sludge. It can be designed as a separate reaction stage or as an individual compartments of a plug flow system. The goal of these selectors is to remove low molecular substrates from the influent under conditions where most filamentous species cannot grow. For example, by exhibiting high BOD concentrations that favors rapid uptake of readily biodegradable BOD by floc formers instead of the filaments. One of the selectors possible is a series of aerated mixed tanks in which the influent is mixed with the return sludge. Typically, a high food to mass ratio is applied. BOD loads of these aerobic selectors are recommended by Jenkins as 12 gram BOD per gram of biomass per day in the first reactor, followed by 6 and 3 grams per gram per day in the second and third reactor. Oxygen concentrations in these types of selectors are preferably high. An SBR type of system can act also very effective as selector, depending on wastewater strength and feeding strategy. This method is for example used in an arena to grow aerobic granular sludge, of which more is shown in the last module. Organisms that are associated with nutrient removal will often grow as floc formers. Therefore, introducing anoxic selectors is also very effective as a prevention of bulking sludge. Even more effective is the use of an anaerobic selector, since that will stimulate the growth of non-filamentous phosphate accumulating organisms, or PAO. The filamentous organisms are not able to consume substrate under anaerobic circumstances, while the PAO can. Therefore, less substrate will be available for filaments. How these PAO function precisely, you will learn in the next module. So maybe you can try to find out the sludge volume index of your nearest wastewater treatment plant and see if they have sludge bulking problems or not. You could try to think of a strategy they could follow to improve their sludge quality. Take your chance to discuss this on the discussion board and see you next time.